everyone! Welcome to my tutorial. I am Joshua Manito from Davao Norte State College. Today, I'm going to discuss to you about spanning trees, Kruskal's algorithm.
Kruskal's algorithm or minimum spanning tree is an algorithm in graph theory that finds a minimum spanning tree for a connected weighted graph. This means it finds a subset of the edges that forms a tree that includes every vertex, where the total weight of all the edges in the tree is minimized. If the graph is not connected, then it finds a minimum spanning forest, a minimum spanning tree for each connected component. Kruskal's algorithm is an example of a greedy algorithm. Builds minimum spanning tree of a graph by adding edges to the spanning trees one by one. To understand Kruskal's algorithm, let us consider the following example. Step 1. Remove all loops and parallel edges from the given graph. So let's remove number 9 and 1. In case of parallel edges, keep the one which has the least cost associated and remove all others. Step 2. Create a set of edges and weight, and arrange them in an ascending order of weightage, cost. BD is 2. DT is 2. AC is 3. CD is 3. CB is 4. BT is 5. AB is 6. SA is 7. SC is 8. Step 3. Add the edge which has the least weightage. Now we start adding edges to the graph beginning from the one which has the least weight. Throughout, we shall keep checking that the spanning properties remain intact. In case, by adding one edge, the spanning tree property does not hold, then we shall consider not to include the edge in the graph. The least cost is 2 and edges involved are BD and DT. We add them. Adding them does not violate spanning tree properties, so we continue to our next edge selection. Next cost is 3, and associated edges are AC and CD. We add them again. Next cost in the table is 4, and we observe that adding it will create a circuit in the graph. We ignore it. In the process we shall ignore / avoid all edges that create a circuit. We observe that edges with cost 5 and 6 also create circuits. We ignore them and move on. Now we are left with only one node to be added. Between the two least cost edges available 7 and 8, we shall add the edge with cost 7. By adding edge SA we have included all the nodes of the graph and we now have minimum cost spanning tree.